Hello guys, my name is Julius Bento and welcome to my presentation. This presentation is going to be about analysis of traffic crashes and weather conditions, and this is presented by me at the CIS 606 Applied Data Mining class. And I want to say thank you to our professor, Dr. JC Martel, for being an incredible professor throughout this journey. Now, let's begin. So, my research question for this project are two. The first one is, how do weather conditions influence the frequency, severity, and outcomes of traffic crashes? And then the next one is, and what target measures can improve road safety under adverse weather conditions? So basically my work was around accident that happens on our major roads during normal days, during snow days, harsh weather conditions, and what are the proportions, what happens, how often do people get accident during a normal day, how often do people get accident during the bad weather conditions. For example, like we had a snowstorm here in Kansas City, Missouri a few weeks ago, and it was that bad. So these are my two questions that I will be looking forward to addressing in this video. Now, traffic crash data description. The description of my data is that the first source of my data is the Chicago data portal. This is where I got my traffic crash data set. Now, the key fields in the data set includes crash records, crash date, weather conditions, damage, which includes the cost of the damages that happened during these accidents, as well as injuries. Are they fatal? Are they incapacitating, or they are not fatal? All of this will be discussed. And also the latitude and longitude, that is where these crashes occur, as well as the size of the data set. Now, let's look at this, the weather data description. Like I said before, I have two sets of data set, the traffic crash data set and then the weather data set. The weather data set was taken from Visual Crossing Weather, and the key fields in this data set includes date, time, temperature, meteorological condition, that is precipitation, wind gust, visibility, cloud cover, and so on and so forth. We have conditions like rain, snow, and clear. Now, let's look at how the data preparation process started. So first of all, before you start any video data analysis, you need to prepare your data. And this includes data import and initial inspection. It includes traffic. And for my case, my traffic data set was from an Excel file. So I uploaded it from an Excel file, and my weather data was from a CSV file. Next one is the inspected columns and data date ranges for consistency. Next is date parsing and merging, and the next one is converted crash date and date time into a common date format, and the last one is merge data set on crash date. So it means that here, after I inspected the data set, checked on everything in there, tried to merge it, and then I have to find a common variable. I have to find a common variable so that I can merge the data set on. In this case, mine is the crash date. So the second part of the data preparation includes cleaning and filtering. Now, when it comes to cleaning and filtering, this is the part where you look at the data set, you check for any inconsistencies. Are there any numbers missing? In which case, in my case, there were some numbers and some months missing. So this really helps for you to check and see all of these things. Addressing gaps in the data set. You need to check up to see if there are any gaps that you need to close, if there are any empty spaces that you need to remove or nullify. All of these are very, very important aspects of preparing your data for a data analysis project. Analytical techniques. Here it includes descriptive statistics and visualization. And then this is me taking my data analysis process and turning them into a visual representation so that people can read into it. People can read meaning into it. So you don't even have to read the whole project, but then by looking at just the visualization that comes out of this project, you will be able to understand what this whole project is about. So these analysis visualizations include bar chart, line chart, stacked bar chart, correlation analysis, time series, and so on and so forth. Now, here we talked about parallelization. Now, what does parallelization really mean? Actually, parallelization actually means like breaking down large or big type of data set or material into smaller pieces so that you can effectively work on them. So in my case, I used the kind of tool that I used in working on my parallelization or my project work was Python, because Python is an incredible data analysis tool that you can use to break down large sums of data sets and then work on them, visualize them, merge them, or even do whatever you want to do with the data. So in my case, I use Python. Now let's look at some of the results of my work. So here you can see that accident count by weather. So here, this is just a few sample of them. You can see that during clear weather period, we have about 1,000 plus accident, right? if you look at the rainy season, we have like 100, cloudy, we have 30, and other conditions, we have like 10. Now here I had a bar chart that shows all of these. So it shows that during like clear weather conditions, actually, there tend to be more accidents during these conditions as compared to like brutal or harsh weather conditions, which do not happen as often as we know. So that is something that really surprised me. And then as we go forward, we will get to know why this is the case. Also, some of the result injuries by weather includes my horizontal stack bar, which shows injury types across weather conditions. And then we also look at clear weather account for the highest injury count. Like I said before, we will get to know why is it that people like have accidents during clear weather conditions and they tend to get more injuries in these. And then we also looked at minority weather types, which is like rainfall, snow and all of that. Now, here we're looking at results of the accident frequency by hour. Per the line chart display in my work, you could see that accident count over like 24-hour period is there. We have the lowest count, which is from between like 1 to 4 a.m. in the morning, and then peaks at the rush hours. That is the mid-afternoon and early evening, because the rush hours are the period when people actually are returning from work. Those are the rush hours, and there is high tendency of accident happening during these hours. Now let's look at the correlation result. Now here you can see that I had a heat map that shows pairwise correlation among numeric features. Okay. Now we use this to show how the numbers and the injuries total, and then what are the numbers associated with the injuries that occur during these bad conditions. Now this is an observation that I had. I realized that using this heat map was not enough. I realized that in the future, maybe I can use advanced modeling, which can help me to get deeper insight into the data set that I'm working on. Now, what are my conclusions and limitations? Some of the conclusions that I saw was that most crashes occur under clear weather. Potential data and reporting bias exists. Now, why did I say this? It means that actually because of the fact that most people drive during the clear weather conditions. For example, if you look at the whole year, most people drive during the whole year under normal weather conditions, and only a few people get problems during the bad weather conditions. So that is why we saw that during the clear weather days, there is a spike in the accident that occurs during these days. Now, let's look at some limitations that I experienced during my work. I realized that some of my data sets were missing. I saw that some of my data sets were not like my months were missing and all of that. So they were like incomplete data coverages, and there was some small like some inconsistencies here and there. Those are some challenges that I faced whilst I was recording or working on this work. And then for the future, what I'm planning to do as a way forward is that I will have to improve on my way of cleaning my data set. I have to improve on my way of merging data set, be able to, scale larger data set or break them into pieces so that I can work on them better. And also I have to learn to use advanced modeling, like get to familiarize myself with other types of data processing tools so that I can be able to get better results for myself. So that is my work, and I hope if you have any questions, you can please feel free to ask. Thank you.